Hello friends, so today I will be solving the numerical problems or exercise problems and some other problems related to lengths with the help of length formula, that is 1 by v minus 1 by u is equal to 1 by f, and magnification, that is h dash by h is equal to v by u. So using only these two formulas I will be solving problems. So it's very simple and it's very easy. So there are 99.9% of chances that you will be getting a problem either from the mirror or from the lens. So it's either one of them, but the formula is only one. In mirror it is mirror formula and in lens it is lens formula. So the terms remains the same. So it's very easy, so don't lose marks. Moving on to the first question. A concave lens has focal length of 15 cm. At what distance should the object from the lens be placed so that it forms an image at 10 cm from the lens? Also find the magnification produced by the lens. So here they have given image distance. So the image distance is image distance. So whenever you are solving the problems, you need to write what is that they have given. So they have given image distance. So the image distance is represented by v. So what is the image distance that they have given? So the image distance that they have given is 10 centimeter. So write down the value that they have given. So whenever you are writing the value, leave some gap in between the equal to symbol and the number. Next, focal length. It is represented by f. Focal length is 15 centimeter. So the lens that they have given is, it's a concave lens. It's a concave lens. So in a concave lens, so if you don't know what is it plus or minus, so what you do is take a rough diagram. So in a concave lens, object is placed on the negative x-axis. Image will also form on the negative x-axis. So focal length is negative, radius of curvature is negative, height of the object and image are positive. So image distance, it is negative because it's lying on the negative x-axis. So image distance is negative. So what is the focal length? Focal length is also negative because it's on the negative x-axis. Focal length is negative. So using this, I need to find what is the image distance. So image distance, I need to use lens formula, that is 1 by v minus 1 by u is equal to 1 by f. So I need to find what is the value of u. So for that, I will take u to the RHS. That is, so 1 by u. So when I take u to the other side, so it will be and I take f to the LHS. So 1 by v minus 1 by f is equal to 1 by u. I know what is v and what is u. So 1 by u, v is minus 10. So write the values inside the bracket. Minus f. F is 15, that is minus 15. So minus 1 by 10, minus into minus is plus 1 by 15. So 1 by u. So what is the LCM? 15 and 20. So 15 and 10. The LCM is 30. So here I am having 10. So if I want to make this 30, I need to multiply with 3. So when I multiply this minus 1 with 3, it becomes minus 3. So similarly here it is plus 1 and below it is 15. So if I want to make denominator as 30, I need to multiply with 2. So I need to multiply 2 on the numerator also. So it is plus 2. So it becomes minus 1 by 30. So 1 by u is equal to minus 1 by 30. So u is equal to minus 30 centimeter. So the object distance is minus 30 centimeter. So With this, if I want to calculate what is the magnification, so m is equal to v by u is equal to h dash by h. I don't know what is h and h dash, so I will use only v by u. So what is v? It is minus 10. So what is u? It is minus 30. So it is 1 by 3, that is plus 0.33. So the magnification is plus 0.33. So magnification is positive for a virtual image, because in a concave lens it's always the virtual image that is getting formed. So magnification is plus in a concave lens, and it is always less than 1. The next question: a 2 cm tall object is placed perpendicular to the principal axis of a convex lens of focal length 10 cm. The distance of the object from the lens is 15 cm. Find the nature, position and size of the image. Also find its magnification. So here what they have given is height of the object, that is 2 cm. So height of the object is 2 cm and focal length is 10 cm. So height of the object h, that is 2 cm. Focal length they have given as 10 cm. Next, object distance. Object distance is 15 cm. So what they have given is, it's a convex lens. In a convex lens, when I take the rough diagram, so object lies on the negative x-axis. So I don't know whether it's a real image or virtual image. So height of the object is positive and object distance is negative. So focal length is positive in a convex lens, according to the sign conventions that we saw. So height of the object, it is positive. So focal length in a convex lens is positive. Object distance, it lies on the negative x-axis. So object distance is minus 15 cm. So with this, I need to find what is the image distance. So if I want to find the image distance, I need to use the lens model, that is 1 by v minus 1 by u is equal to 1 by f. So I need to find v, that is 1 by v is equal to 1 by f plus 1 by u when I take u to the other side. So what is f? It is 10. So it is plus 10. So when there is plus, you can skip that. So it is 10 plus u. U is minus 15. So minus 15. So the LCM is 30. So if I want this 10 to become 30, I need to multiply with 3. So when I multiply 3 on the numerator, it becomes plus 3. Plus into minus is minus. So 15, if I want to make it 30, I need to multiply with 2. So similarly, I need to multiply this with 2. So it becomes 2. So 1 by v is equal to, so 3 minus 2 is 1 by 30. So v is equal to 30 centimeter. So it is positive, because here I am not getting it. I am not getting minus. So obviously it will be positive. So v is positive. It means that the image is getting formed on the it is getting formed on the positive x-axis. If the image is formed on the positive x-axis, it means that it is real and inverted, because only the real image will form on the positive x-axis in a convex lens. So what is the nature? It is real and inverted. So if I want to see the magnification, so what is the magnification? So m is equal to h dash by h. This is equal to v by u. So m is equal to h dash by h is equal to v by u. So I know what is h. I need to find h dash. I know what is v and I know what is u. So h dash is equal to v by u into h. So what is v? V is 30. What is u? U is minus 15. So what is h? H is 2. So 2 is a 1 are. So 2 into 2 is 4. But here I have a minus. So it is minus 4 centimeter. So why did I get minus? Because it is real and inverted. It is inverted image. So inverted means it is on the negative y-axis. So obviously the height of the image should be negative. Hence I am getting minus. In case if you are getting positive, if you get image distance as positive and even the height of the image is also positive, it means that you have done a mistake, because for a real and inverted image distance will be positive, whereas height of the image will be negative. So if you are getting something else apart from this, means that you have done a mistake in the calculation. So we can cross verify like this. So next question. An object 5 cm in length is held 25 cm away from a converging lens of focal length 10 cm. Find the position, size and nature of the image. So here what they have given is, it's a converging lens. So converging lens is only convex lens. In a concave lens it is diverging. So concave lens is diverging and convex lens is converging. So it's a convex lens what they have given. So what they have given, height of the object, that is 5 cm. So when you draw a rough diagram, so this is the object. So focal length and object distance. So height of the object, it's always positive because it's always placed above the perpendicular, that is principal axis, perpendicular and above principal axis. So height of the object is always positive. So until and unless they have given some other condition. Focal length. Focal length in a convex lens is positive. So because it's forming on the positive x-axis. Object distance. Object distance is always negative. So it is negative. So with this I need to find what is the image distance. So lens formula, 1 by v minus 1 by u is equal to 1 by f. So I need to find what is v. So 1 by v is equal to, if I take u to the other side, it will be 1 by f plus 1 by u. So what is f? It is 10. So plus 10. So what is u? It is minus 25. Minus 25. So 10 and 25. The LCM is 50. So it's 1 by v. So LCM is 50. So if I want this to become 50, I need to multiply with 5. So similarly in the numerator. So 185 is 5. So plus into minus is minus. So 25, if I want to make it 50, I need to multiply with 2. So similarly when I multiply the numerator with 2, it becomes 2. So 5 minus 2 is 3 by 50. This is 1 by v. So this is just 1 by v. So whenever you are writing, so write this also, because if you skip this, so here if you make or if you write 1 by v in the starting and if you don't write anything here, so there are high chances that you make mistake. How? So finally you write v as 3 by 50, but it's not so. You have to write the reciprocal. So when you take the reciprocal, it becomes 50 by 3. So it's most of the students that you make mistake. It's not just you. Even when I was in 10, I did the same mistake. and even my friends were also doing the same mistake. So with that, I am telling, it's not just by seeing the students that I am telling that you make mistakes. It's even what I did and what my friends did. So that's the reason why I am telling. So whenever you are writing, so write the value here. It's like 1 by v, 1 by v, 1 by v. So whenever you want to write the final value, you'll be knowing that it's not v, it's 1 by v. So when you want to get the value of v, what you need to do? You need to take the reciprocal. So v is equal to 50 by 3, which is nothing but 16.66 centimeter. So it is plus. If you get plus, it means that it is real and inverted, because it is forming on the positive x-axis. It is forming on the positive x-axis. It is real and inverted because it is the image distance is positive. So with this, I want to find what is the height of the image. So m is equal to h dash by h is equal to v by u. So I need to find the height of the image, that is h dash is equal to v by u into h. So what is the value of v? So instead of taking 16.66, so when you are calculating here, so try to take the fractions as it is, because the simplification becomes easy. So 50 by 3. What is the value of u? U is minus 25. It is minus. So you have to write minus into h is 5. So 25 ones are 2s are. So 3 goes to the denominator. So it is 2 into 5. It is 10 by 3. So which is nothing but 3.33. So it is plus 3.33. Is it plus or minus? It's not plus, it's minus, because it is real and inverted. In lens, when it's real and inverted, the magnification is negative. So what is that you made mistake? When you see here in the denominator you have minus 25. So nowhere else there is minus. So it's only 1. So it is minus. So this becomes minus 3.33. So whenever you get the final answer, if you want to cross verify, this is how you can do. So I did the same thing in mirror. So in lens also you can do the cross verification by getting to know whether it's positive or negative and it's correct or wrong. So magnification is minus 3.33, and magnification is a unitless thing because it does not have any unit, it does not have any dimensions. Next, a concave lens of focal length 15 cm forms an image 10 cm from the lens. How far is the object placed from the lens? So here what they have given is, it's a concave lens and the focal length of a concave lens is 15. So and the image is getting formed at a distance of 10 cm from the lens. It means that image distance is 10 cm. So if you want to write whether it is positive or negative, so take a rough sketch. It's a concave lens. Object is placed always on the negative x-axis. So image will also form on the negative x-axis because it is virtual and erect. So what is the focal length in a concave lens? As we saw in the sign convention, focal length of a concave lens is minus. So similarly, image distance in a concave lens. Image distance in a concave lens is negative because it is getting formed on the negative x-axis. So with this, using lens formula, that is 1 by v minus 1 by u is equal to 1 by f. So I need to find what is the object distance. So I know what is v, I know what is f. So let me take u on to the RHS. It becomes 1 by v. When 1 by f comes to the LHS, it becomes minus 1 by f. It is 1 by u. So 1 by u. So what is the value of v? It is minus 10. So write it inside the bracket. minus f is 15, that is minus 15. So LCM is 30, so it is minus. So this 10, if it has to become 30, I need to multiply with 3. So 1 into 3 is minus 3. Minus into minus is plus. So 15, if it wants to become 30, so I need to multiply with 2. So similarly in the numerator, it's 2. So it is minus 1 by 30. This is 1 by u. So what is the value of u? It is minus 30 centimeter. So obviously the object distance should be negative because it is placed on the negative x-axis. So in case if you get the object distance was positive, until and unless they have not given any condition in the question, until and unless they have not given any conditions, if you get the object distance as positive, it means that you have made some mistakes in the calculation. So object distance is always negative. So object distance we need to get as negative, that is minus. So object distance is minus 30 centimeter. Next, the magnification of an image formed by a lens is minus 1. If the distance of the image from the optical center of the lens is 35 centimeter, where is object placed? What is the nature and focal length of the lens? If the object is displaced by 20 centimeter towards the optical center of the lens, where would the image be found and what will be its nature? So here what they have given is magnification produced by a lens is minus 1 and the image distance, that is the distance of the image from optical center is 35 centimeter. This is all what they have given. So they have not given whether it's a concave lens or convex lens, or else they have not even given whether it's a converging lens or a diverging lens. So you need to check what kind of lens it is. So how do you do it? Here they have given magnification, that is minus 1. So with the help of magnification we can get to know whether it is a concave lens or a convex lens. Before writing whether it is positive or negative, we need to find whether it's a concave lens or a convex lens. So magnification, it is h dash by h. So what is the value that they have given? It is minus 1. So it means that h dash is equal to minus h. So what does this mean? If the height of the image is positive, then height of the object will be negative. So where is this kind of thing formed? It's only formed in a real and inverted image. How? So when I take, real and inverted image is formed only in a convex lens. So if the height of the object is positive, so if I take height of the object as positive, so what will it be? So minus into positive. So negative into positive. So let me write like this. So it's minus x, negative. So here height of the object is positive. So negative into positive is negative. So obviously the height of the image, if it is real and inverted, it will be negative. So if I take a concave lens, it's always forming virtual and erect. So height of the object is also positive, height of the image is also positive. So both the heights are positive, but here it should be opposite. Means if the height of the object is positive, then height of the image should be negative. This is how it should be according to the sign convention. According to the sign convention, the height of the object cannot be negative. So it should always be positive. So in that case, height of the image will be negative in a convex lens for real and inverted. So this is how you can find. So concave lens cannot be the lens which is used here. So it is convex lens and it's forming real and inverted image. So what will be the image distance? If it is real and inverted, image distance will be positive because it is forming in the positive x-axis. So h is equal to h dash by h, you got to know whether it is concave or a convex lens. So magnification is -1. So it means that so if I take image distance and object distance, so m is equal to v by u is -1. So what is v? It is equal to -u. It means that object distance and image distance are the same. So I need to find what is u. So u will be -v. That is -35. So object distance is -35. Obviously it should be negative because object is placed on the negative x-axis. So object distance is negative and it is -35. So with this, if I want to find, so what will be the nature of the image when object is moved 20 centimeter towards the optical center. So for this I need to find what is the focal length. So if I get to know the focal length, I can calculate the other things. So when here object distance and image distance are the same, so it is formed only when the object is placed at center of curvature. Only when we place the object at center of curvature. So this is a convex lens, f1, c1. So when I place the object at c1, the image will be formed at c2. So only for this condition, it means that the radius of curvature is same as the object distance, because this is the object distance. So the radius of curvature will also be 35. So radius of curvature is also 35 centimeter. So if I know what is the radius of curvature, I can find focal length, that is r by 2. 35 by 2, it is -17.5 centimeter. So I got to know what is the value of focal length. So with this, when the object is displaced 20 centimeter towards the optical center, so initially it was 15 centimeter. So when I move the object 20 centimeter towards the optical center, so it means that this distance is 17.5 centimeter. This is 17.5. So similarly, this distance is also 17.5. So when I move this 20 centimeter towards the optical center, the object will be placed somewhere here. That means it is placed between the optical center and the principal focus. So what will be the nature of the image? When I place an object in between the optical center and principal focus, the image will be formed behind the object. So it is virtual and erect. So what is the nature of the image? It is virtual and erect. So I need to find what is the image distance. So if I want to find what is the image distance, I can calculate using the lens formula. That is 1 by v minus 1 by u is equal to 1 by f. So here u is 10 centimeter and f is 17.5 centimeter. So using these values, I can find what is the value of v. So I will give this as an assignment. So calculate the value of v and drop a comment in the comment box. So let's see how many of you will solve it correctly. So v, you need to find what is the value of v, calculate and comment in the comment box. So be careful with positive or negative and try to see what will be the answer that you are getting. So thank you. Have a good day.